Dear viewers, welcome to this video on exponential smoothing technique. In the past videos, we have used most techniques like weighted moving average, naive based methods for forecasting the demand data. Today, we will use this exponential smoothing for forecasting the demand data. In exponential smoothing, the demand data is forecasted based on the past data. The difference between the moving average method and exponential smoothing method is that the moving average method uses the equal weights to the past data, whereas exponential smoothing method uses decreasing weights to the past data. And one more important difference is that weighted moving average uses a particular time window, wherein for example, moving average for a 3 period moving average will use only 3 periods, whereas exponential moving average uses the data for all the past data. In weighted moving average, we will have the weights for the previous periods given in progressively decreasing. Sometimes this weight has to be changed with help of the forecaster's input, and the importance of this weights may be varying based on the application also. Now, let us see how this exponential smoothing varies between the weighted moving average. In exponential smoothing also, we are giving some weights. These weights are given with help of the smoothing constant. The smoothing constant will be like giving the weights in progressively decreasing manner from the recent to the very past data. Whereas in weighted moving average, we have taken a time window. For example, a 3 period moving average will have a 3 period window, whereas 6 period moving average will have a 6 period window. And these weights will be assigned by the forecaster himself, and the forecaster may give the weight based on the recent past and how the application is requiring the weights, and the weights may also be varied based on the importance of the period. If the application requires highest responsiveness, the weights to the recent data will be higher. So, that is how the weights are assigned. Now, let us see how this key concepts of exponential smoothing can be explained here. One of the first key concept is weighted average. As I said, in simple moving average, it is an assigned weights to the past observation for a particular window, whereas in exponential smoothing, it is an assigned weight in a decreasing order, which is exponentially decreasing. And the next important thing is smoothing parameter, which is a smoothing constant called as alpha, beta or gamma, where these values varies between 0 and 1, and these parameters helps us to adjust between the responsiveness and the smoothness. And the third thing is recursive calculation, whereas in exponential smoothing, this recursive calculation is one in which it has all the past data in it, and it makes it computationally efficient and suitable for real time applications. Now, let us move on to the types of exponential smoothing. The types of exponential smoothing, we can see there are three important types. One is simple exponential smoothing. The second one is double exponential smoothing, or otherwise called as Holt's model. He is the person who have identified this method, and or otherwise called as trend adjusted exponential smoothing, because it varies from the simple exponential smoothing in identifying the trend. When some data is available with the trend, if we use simple exponential smoothing, it may not predict the data with higher accuracy. So, in order to predict the data with higher accuracy wherever we have trend, we may use this trend adjusted exponential smoothing. And the third method is triple exponential smoothing, or otherwise called as Holtz-Winters model, or otherwise called as trend and seasonality adjusted exponential smoothing. So, when the data is having both trend and seasonality, then we may go for triple exponential smoothing. Now, let us see how this exponential smoothing method works. This is a very simple formula used for exponential smoothing. The forecast for the time period t can be identified using this formula alpha dt minus 1 plus 1 minus alpha f t minus 1, where f t is the forecast at time period t and alpha is the smoothing constant for value between 0 and 1. D t minus 1 is the previous period demand and f t minus 1 is the previous period forecast. Now, you can see that in exponential smoothing how this tracks the past data. Now, let me take f t plus 1. F t plus 1 will be equal to alpha. If I add t plus 1 here, d t plus 1 minus 1, this 2 will get cancelled, it will become t plus 1 minus alpha into f t plus 1 minus 1 will be again t. Now, let us replace this with this f t with this formula. So, now it will become alpha dt plus 1 minus alpha into f t can be written as again alpha dt minus 1 plus 1 minus alpha into f t minus 1. So, if we rewrite this, it will be alpha dt plus alpha into 1 minus alpha dt minus 1 plus 1 minus alpha whole squared into f t minus 1. So, you can see that, so this is alpha into dt, this is alpha into 1 minus alpha into dt minus 1. So, we are taking all the previous data and we are also taking the forecast. Now, this will have another formula which tracks the previous data. So, this will keep on going like this. So, this never ignores any data point available with this, and this exponential smoothing helps us in having the information about the past for all the forecast in the near future. Now, let us take a small example and see how this exponential smoothing can be calculated. Imagine that you are a sales manager for a retail company. You have recorded the monthly sales data for past 6 months and you want to forecast the sales for the next month using simple moving average. The next month will be 7th month and they have given assume alpha as 0.3. We will see the variations in alpha little later. Now, let us see how this can be forecasted. For the first period, we do not have any forecast now. So, we are taking the forecast as it is actual sales. For the second period, we will take the forecast as alpha value is 0.3, I am taking 0.3 as it is, 0.3 into dt minus 1. dt minus 1 is 50 plus 1 minus alpha is 1 minus of 0.3 into f t minus 1, f t minus 1 is 50 again. So, I will redo it here, it is 0.3 into 50 plus 0.7 into 50. So, 0.3 into 50 plus 0.7 into 50 will be another 50. So, the forecast for the second period is taken as 50, but the actual demand was 55. Now, let me go back and calculate the third period's forecast. Now, let us try how to calculate this. So, it is again alpha is 0.3 alpha dt minus 1 into dt minus 1 is 55 plus 1 minus alpha. So, 1 minus of 0.3 is 0.7 multiplied by f t minus 1, f t minus 1 is 50. So, let us calculate this. So, 0.3 into 55 plus 0.7 into 50, that is equal to 51.5. So, this is the forecasted data for third period, but the actual demand is 53. Now, let us try to calculate the fourth period. Fourth period is again we have to alpha value, take the alpha value, alpha is 0.3 multiplied by dt minus 1. Now, dt minus 1 for fourth period is d3, that is 53 plus 0.7, that is 1 minus alpha is 0.7 multiplied by previous forecast, that is 51.5. So, that is equal to 0.3 into 53 plus 0.7 into 51.5. So, it is 51.95. 51.95. The forecasted data is 51.95, whereas the actual is 58. Now, let us try to forecast for the 5th period. You can pause the video once and you can try this and recheck the values again. 0.3 into previous period demand is 58 plus 0.7 into previous period forecast is 51.95. Upon calculation, let us see how this comes. 0.3 into 58 plus 0.7 into 51.95, that is equal to 53.765. The forecasted data is 53.765, whereas the actual demand is 54. Now, let us calculate it for 6th period. It is similar to 5th period, but only we have to change the data here. 0.3 into previous period demand is 54 plus 0.7 into previous period forecast is 53.765. Let us calculate it. 0.3 into 54 plus 0.7 into 53.765. So, it is 53.83. Let us take up till 3. And if we want to forecast for the 7th period, it will be like 0.3 into previous period demand is 57 plus 0.7 into previous period forecast is 53.835. We will see what value comes in. 0.3 into 57 plus 0.7 into 53.835. So, that turned out to be 54.785. 45. But actual may be different, that is yet to be known. The forecaster may say that the anticipated sales for 7th period may be 54 and actual may be something different or near to it. So, this is how the exponential smoothing method helps us to identify the forecast in the future. So, the major difference between the moving average and exponential moving average is that in moving average we average the data and identify the forecast, whereas the time window is fixed. Whereas in weighted moving average, we give some weights to the data within the time window, whereas in exponential smoothing, we give weights to all the data in our we give weights to all the available data. So, that is how these differences comes in. Now, let us see how this alpha plays a role in exponential smoothing. Thank you.